a heads up, there's going to be some audio clips and video clips during this. So today I'm going to talk about Genesis and the software that Genesis provides. Just as a quick introduction of a short clip. So what is Genesis? It's a company founded in 1999 in the south of France. Genesis joined OPTIS about 2 years ago. OPTIS, as some of you may or may not know, specializes mainly in lighting simulation tools, but we are now starting to get into the sound sector, and we're working to collaborate both light and sound inside of some virtual reality simulators. So Genesis is now the Acoustics Research Center for OPTIS, and we are supporting it worldwide. I am the local, acoustics specialist for the Genesis products. And so, just like OPTIS, Genesis provides consulting projects. There's dedicated software for simulation as well as for virtual reality. They also provide software products for acoustics expertise, and we'll get into some of the different software that we can offer later on. Kind of the bread and butter of the Genesis tools is something called LIA, and this is our virtual acoustic lab. So we can evaluate sound and also design sound. And it all starts with a recording. So you record your sound, whether it's an engine sound from a driver's point of view, or it's the clicking of a rotating HVAC knob, or the clicking of a button. You record your sound, and we can play it back, analyze it, as well as add to that sound to make it better perceived by a user. Once we've analyzed and designed our sound, we can take it into what we have called GeneStudio, which allows us to play back transaural sounds with 2 to up to I believe, 16 speakers. And this allows you to do a 3D sound rendering. So the sounds that you're hearing are actually, you're fully immersed in that sound, and we can hear where certain things are coming. So if a plane is flying over our heads, we can hear it coming from the left ear over to the right ear. And these speakers cancel out so for example, the right speaker will cancel out the noise going to the left ear, or the left speaker might cancel the noise going to the right ear, vice versa. We'll get into more examples a little later on. We also have Janice, which allows us to take this sound and implement it in a driving simulator. So it is compatible with other driving simulators other than our own, and it is in addition into your visual driving simulator. It's actually reading the pedal position or the RPM signal, and it's playing your engine noise based off of those inputs. And then we also have a product called ASD, which is an acronym for Active Sound Design. This gives us the ability to enhance our engine sound and create a sound that we want our engine to sound like, and then use that as our end goal in terms of if we like a certain engine sound, then we go back and try to replicate that in a real-life scenario. And that can be implemented directly into a vehicle. We also have some hardware that allows us to take that engine sound and plug it into your vehicle and enhance the engine noise. So if you want your vehicle to, if you have a 4-cylinder vehicle but you want it to sound like an 8-cylinder, you can do that from an interior standpoint. So from the driver or passenger's ear, we can have it sound the way we want it to. Some of the main market sectors for these products: automotive and other motorbike, trucks, and bus. Just some examples here for some of the companies that we're working with. Also, Tier 1 suppliers, aerospace, railway, and defense, and then combination of luxury goods, electronics, research. So here's an overview of the process of taking a recording of a sound and going all the way to implementing that particular sound. So we start with a recording, obviously. So you can see in the image on the left, we have a dummy head with binaural microphones in the ears, and it's recording a sound inside of a lab. And that way it's getting both the left and right ear signals. So when you go to play that sound back, we still have those left and right ear signals. So it takes into account the ear canal. These binaural microphones can also be put in to a user's ear, and it will take into account that user's ear canal as well. From that sound recording, we then take it into LIA, and we are able to play back the sound and also separate the sound. So for example, if we're recording an engine speed up, we might, if we're actually driving on the road, we might have a combination of wind noise and also the engine. So we can record that as one sound, then play it back in our software and actually visualize the two separate sounds inside of that. So we can remove the wind noise and just focus on the orders of the engine. We also then can take it into a 3D playback room, so we can use something as simple as headphones. Then we can also use more of a stereo speaker setup. And then finally, we can do psychoacoustic measurements where you are playing a sound to a user, and people are rating each sound and how they perceive each sound. And then based on that measured perception, we can come up with a formula that can be estimated before we even, so we don't have to play back the sound for another test group or something like that. So we can come up with an estimated perception value to know that the user may or may not like this based on a ranking, in this case 7.5. So just some of the things we're going to discuss going forward, some of the trends and challenges of sound design, as well as the product overview of all of the products that I've been showing so far. And then at the end, we will show a few references, case studies, and some customer projects. Some of the trends affecting sound, well, in terms of automotive, is the emergence of electrical vehicles and ADAS-enabled vehicles. So for electric vehicles, we're losing that engine sound, and it can be a bit weird for some people to experience. And not only inside the vehicle is it different, but also outside of the vehicle. So and that relates to ADAS as well. So being able to hear a vehicle coming from the outside without an engine is something that people are becoming more and more concerned about with the emergence of electrical vehicles. And then also inside a vehicle, if you're losing that engine noise, you start to pay more attention to other sounds in the vehicle. So maybe when your radio's off and there's no engine sound, you start to pay attention to your windows rolling up, they sound really loud, or your volume knob for your radio might sound extra loud because of that lack of sound coming from the engine. So we can use this software to replicate an engine sound inside the cabin, not based on an RPM signal, because with an electric vehicle there is no RPM signal, but based off of the pedal position. And so, that gets into the psychoacoustics. So how there may not be a parameter in terms of the sound quality, but it comes down to what a user thinks is good or bad, and being able to come up with metrics for that to predict it in several different designs. And then also engine downsizing. So as more and more OEMs are trying to be more efficient, you're seeing vehicles go from a V8 down to a 6-cylinder or a 4-cylinder, and the engine sound is changing quite a bit. So a consumer who is used to hearing a very loud, for example, a very loud Mustang, and then they're reducing the amount of cylinders, the engine might sound a bit different, which may or may not be acceptable for some people. So we can add that sound to the target sound, to reach the target sound. So our offer is going from measurements to sound design, and we're trying to place the human perception at the center of the design process. So it's very quick to get a sound, to play it back, and perceive it. There's other ways to analyze it. You can see the picture on the left have all these wires that are measuring specific sounds in coming from this vehicle. But in the end, it really comes down to how the customer perceives it. So we are focusing more on the human perception. So the process in a very simple manner is to analyze the sound, create a target sound that we want it to sound like, and in doing so, we will hopefully improve the perceived value. So some different departments, mainly, I think these are just touching in automotive. Obviously, the engine and powertrain, I think, are a no-brainer, but also body and structure, analyzing wind noise, for aerodynamics, and also simulating, driving simulators, as well as the virtual reality spaces, and then audio and multimedia. Going back to some of the buttons and switches and knobs, the perceived sound of that as well. So this is just showing a car and all the different noises that comes from it, and this goes back to the previous slide that explains where some of those departments might have issues when it comes to their sound quality. So we have pass-by noise, as well as sound designed for electric vehicles. We have HVAC noise, so not even just the knobs, but also the air coming through the vents. The wind noise around the vehicle, the exhaust noise, the engine noise, the quality of a car door slam. Some people don't realize it, but as you close the door, if you're at a dealership, you might hear a very satisfying door slam sound that can sometimes sound safe and then not safe, depending on how the door sounds. Not something that you may think about, but subconsciously maybe you are. And then also car tire rolling noise, as well as engine cooling noise. So again, dealing with fans. So to get into the product overview, we're going to start off with a product called LIA. This is our Sound Lab. It's a very user-friendly software. A lot of our users may use it for a short period of time and then not use it for several months, and they've claimed that it is very easy to pick back up, and it's a fairly simple, easy-to-use tool. So inside LIA, we can do sound design. We can separate our sound sources and denoise them. So going back to my example about separating wind noise and engine noise, or separating a turbo sound from an engine. Also troubleshooting different sounds and then coming up with a psychoacoustics criteria. And so as one user said from Volkswagen, they referred to this as the Photoshop for sound, because it's the way I interpret that is because it's very user-friendly and you can modify things very, very easily. So just a few examples. I'll play a few sounds that represent what we can do inside of LIA. Sometimes it's hard to just show it in pictures because we're dealing with sound, so it's a bit different than some of our lighting presentations. So this is the initial starter for Valio. They have a starter motor noise case study. And it may be hard to hear over the webinar, but we can hear a faint whistling sound, which you'll see here are these orders the streaks going through here. So this is separating that whistling sound from the rest of it and removing that obnoxious noise. So then finally we hear the engine noise without the whistling sound. Another example, we were talking about the car door slam. So this is an original car door slam. We're looking at it in terms of a time frequency graph here. One attempt was to remove the low frequency to see if that has a better quality, and it was discovered that it did not. The original versus, so you're losing that deep sound. The best case was actually removing the medium frequency and keeping that deep sound. It sounds like a more solid car door slam now. So playing the original, first attempt, and finally the last. So we're able to just rub out those specific frequencies and use that as our target sound to go back and design a better solution. This is an example of the engine run-up. I'll play the original, and then we're going to show how it can be broken down into just the engine sound and separate that from the wind sound, as well as the tire. That's the run-up of the vehicle, and you can hear the engine noise and the wind noise. So now we'll just list, we can actually select just these specific orders that we want and listen to them isolated. And then that versus just the wind noise. So you might have one group that's interested in the wind noise and one that's interested in the engine sound. So just from one recording, you can separate that into the two respective sounds. And this is an example of how to actually inside the software. It's a good example that walks through some of the different tools. Just a quick video I'll just play. So we can hear that bird whistling in the background of the engine noise, and we're going to select just that bird whistling and isolate it. So what we saw in that video was bird whistling in the background of an engine sound, and we're able to isolate that specific sound as well as just simply using our, you can do that using our magic wand tool, and then you can also rub out that sound so it takes the values around it and fills in that the space where the whistling was, and then in that way you're able to remove that sound. And for in terms of the LIA software, some of the feedback that we've gotten is that it's very powerful. I'm not going to read all these quotes, but feel free. I think the second one is really nice. Something that used to take a half an hour is now taking them 2 minutes. You're saving time in a few different steps of the process. Not only you're saving time to record the sound and use that over and over as a target sound, but it's very easy to isolate and remove certain sounds. And then you've seen this slide already, but just to show some of the different customers that are using this particular software. Moving into another aspect of Genesis is Genicars. So this is our 3D sound for driving simulators as well as for virtual reality. So we can implement our sounds into many different driving simulators, including OPTIS VRX, but it's not limited to just that. But you can also use Scanner as well as others. So with this, we can play back both the original sound and the synthesized sound, and use either headphones or using 2 to 16 different loudspeakers. So this is just another example showing the software implemented in a driving simulator. And this is more or less the process in a very simple sense. So we have the simulator system that is providing an RPM signal, speed, throttle position, and we can use that to go along with our engine noise to change at each different engine RPM and play back that sound in a 3D sound system. So we can control each of our synthesized sources separately inside of Genicars. So we can take into account RPM, engine architecture, aerodynamics, car speed, tire speed as well, including some different environments such as a wet road versus a dry road. It can also be used to simulate the sound of some wipers during a rainy day, and also a car radio. So Genicar is able to use data sets from either LIA or MATLAB. So just a quick example of Genicars. So we're able to switch back and forth between our original sound and our synthesized sound that we've created in LIA. And then you not only can you play it as an engine run-up, but you can actually pause it at a particular RPM and listen to that sound. And at the bottom here we have some of the different orders that we've separated into, and we can control those independently and see how that affects the sound at this specific RPM. This brings us to our next topic, which is Janice Studio. This utilizes a few things, not only the binaural microphone for an artificial head, but also allows us to take those two separate signals and play back with loudspeakers as well, using crosstalk cancellation. Some of the advantages of doing this, so taking a binaural recording and bring it into a 3D sound environment, we can utilize a few key benefits, which is we don't have the source movement while we're turning our head if we're using, as opposed to using headphones. So by turning our head, we can actually notice the difference of where that sound is moving to. We can also get sometimes better low frequency and even some to even feel the sound in a way. I'm going to play this one. It might not work very well over a webinar, but this is just showing with only 2 speakers what you can do with a recording.
Hello and welcome to the universe of 3D sound. With Genesis technology, you can create or reproduce natural sounding acoustics. Listen closely. Right now, I'm on your left. Now, I'm on your right. Do you hear me? Now, I'm speaking to you.
So for the people that are actually attending here in person, they can perceive this better because I actually have some pretty loud speakers in our room here. So you can actually, standing in front of these 2 speakers, you can identify where the sounds are coming from. So going from, it sounds like someone is talking to you from the left side versus in front of you versus the right side. So over the webinar it doesn't sound very good, but for the people in attendance here, it sounds much better. That brings us to our active sound design solution, or ASD. So this is specific for automotive designing or enhancing a sound for an engine noise. And once we design our sound, we can actually implement it into a vehicle using what we have. It's called a Genibox, and we take our final designed sound and we're able to play it back through the audio system, and meanwhile using the feedback from the CAN bus in terms of the RPM signal. and it will play your added sound in addition to the existing engine noise. So as usual, we have our baseline sound recording, then we do our sound analysis with LIA. Then we're able to take it a step further and actually do some fine tuning. And you can see very faintly here we have our original sound for one specific order. And we're actually able to hand draw our own additive sound. Once we get to something that we like, then we can save that sound, and we have with our JanaBox, it comes with a tablet, and we preload our sounds on this tablet. We plug in the JanaBox to the OBD2 port to read the RPM signal, and it will play your specified sound in addition to the engine noise. So if you're driving a 4-cylinder and you create a sound that will hopefully make it sound more like an 8-cylinder, you can actually, using the pedal position and the RPM signal, we can play back a specific sound, target sound that we want to hear. Some people have actually even implemented this in production vehicles. So in a Renault Clio that was launched in 2013, the drivers were actually able to choose the sound of their engine in their audio system. So you see at the bottom right, there's a picture, and you can select several different vehicles that you want it to sound like for the driver from the cabin. This is a demo about that Renault Clio and how it was implemented in their vehicle. Okay, we're not going to play that one. So using the JanaBox, picture on the right just simply comes with a tablet and the JanaBox, which has the CAN bus connection. It's very easy to use. There's an app that's installed on it where you load in your sounds as well as the configuration to read your specific RPM signal, because each is different for every car. Not every car, but every manufacturer. So going back again to a slide I showed earlier, kind of to bring it all back together. So LIA, everything kind of starts there, and from LIA, after we've analyzed and designed our sound, we can take it into either GeneStudio, GeneCars, or engine sound design tools. So just some, to conclude, we have some references of specific use cases. So for an aircraft company, they use some of our software to study the noise emitted by different engine technologies and also improve it. So some of their benefits was the ability to deeply analyze the sound and also design it efficiently and precisely. So they're using LIA Psychoacoustics, as well as an option to analyze orders. A couple electronic references. A team of audio engineers use Genesis to improve their analysis tools. So edit, analyze, and denoise sounds. Again, improved efficiency using LIA. Another electronics using for a printer to have a better perceived sound coming from your printer. Everyone knows that printers can be extremely loud sometimes. And then also in the marine sector, a research company was actually looking at the sound of their the underwater sound of their submarines. So using LIA and extract allows you to actually extract certain frequencies from your sound. Aerospace, another example for not only the inside aircraft noise, but also outside. So even looking at from a consumer standing at the ground and they hear a plane coming overhead, they're interested to know how that sounds to them to improve their perceived quality of their engine noise. Not just the engine noise, but also the aerodynamics and other things that go into that. Again, another example of, in this case, with a helicopter. And then also in railway, interior and exterior sound. So if you were present during Kishore's presentation earlier, you saw this as well, just some of the different offices we have worldwide. And right now we are in the Detroit office. And just one other thing to add, and I think I missed in some of these slides, was that Janice's tools can be implemented in addition to existing tools, whether it's LMS. We can take sounds that were recorded by other software and hardware tools and implement this in addition to that. So it's compatible with many other acoustics softwares as well. Thank you for joining today. Thank you for joining Kishore's if you were here as well earlier. And I'm going to open it up for questions. If you have any questions, please feel free to type them in the chat, and I will do my best to answer them. And if you have any sales questions, please either contact your account manager if you know them, or you can simply email the email up here, as well as any technical support questions that may come after today. Maybe you think of something tomorrow. You can email us at our support email as well. So, any questions?
We'll leave the... Sorry about that. We'll leave the question forum open for the next 5-10 minutes if anyone has any questions. Also, I'd like to invite anyone attending here to come to our office for future webinars and attend in person. That way you get a chance to talk with us as well, and we do provide lunch as well during the webinar sessions. So please keep that in mind as well as an option for the next webinar.